Hello everyone. Today I am here to discuss a topic on subject probability theory and stochastic process. My topic is today I am here to explain a total probability theorem. Before going to this concept, let me introduce about this concept. The total probability theorem sometimes calculating the probability of an event directly is hard. So the total probability theorem helps by splitting the problem into smaller, easier parts based on the conditions. It is like saying, if I can't find the answer directly, then I will break it into smaller parts and I know and then add them together. Let us imagine an example for our better understanding. Let all of let us imagine we have three factories. They are factory A, factory B, and factory C. Uh, Assume that all the three factories makes bulb. So you know how many bulbs each factory makes. Let us consider the bulbs made by the each factory is P of Bn. The probability that the bulbs from each factory are defective. Let us consider the defective bulbs as P of A by Bn and the bulbs made by the each factory is P of Bn. Now, what is the total probability that a randomly chosen bulb is defective? Here, the total probability theorem helps us to combine probability that the bulb came from the each factory and the probability that the bulb is defective from that factory. Total probability theorem or law of total probability. Let me explain you the statement of the theorem. Let B1, B2 and so on Bn be a set of mutually exclusive and exhaustive events in a same sample space S. That is Bi intersection Bj equals to phi for all I not equals to j, where I comma j equals to 1 to and so on, and here 1 to n are mutually exclusive. B1 union B2 union Bn is equals to S. They are exhaustive events. Let A be any event in S. Then the probability of event A is given by P of A is equals to summation n equals to 1 to n. P of A by Bn into P of Bn. This is called as total probability theorem. We can find the total probability theorem in four steps. The step one is partitioning the sample space. From the given, we know the sample space S is completely divided into B1, B2 and so on Bn. These are disjoint events. No two events overlap. That is Bm intersection Bn equals to phi for n not equals to n. Every outcome in the sample space belong to exactly one of the Bn. Thus, the set of events B1, B2 and so on Bn partition the sample spaces. For better understanding, let me explain you. Let us consider A as n sample space. We have to find the probability of A, but it is difficult. So I am partitioning the A into several parts like B1, B2, B3 and so on up to Bn. From that I will add all the partitions which are included in the A. That helps me to calculate what that helps me easily calculate. For step 2, express the event A using partition. The event A lies within the sample space S. Here the event A lies within the sample space S, which is made of disjoint union of B1, B2 and so on Bn. So we can write as A equals to A intersection B1 union A intersection B2 union and so on union A intersection Bn. This means the event A can be broke into parts, each part occurring along with a different Bn also. Since the Bn are mutually exclusive, the intersection A intersection B1, A intersection B2 and so on A intersection Bn are mutually exclusive. Now let me explain the step 3. Step 3 of total probability theorem. The step 3 is to apply probability to disjoint union. Since the intersections are mutually exclusive, so P of A equals to P of A intersection B1 plus P of A intersection B2 and so on plus P of A intersection Bn. Using summation notation, we get an equation as P of A equals to summation n equals to 1 to n P of A intersection Bn. Step 4 to find the total probability theorem is use conditional probability definition. We use conditional probability definition to find the total probability theorem. By the definition of condition probability, P of A by Bn equals to P of A intersection Bn by P of Bn. Multiply both sides by P of Bn. Then we get P of A intersection Bn equals to P of A by Bn into P of Bn. Now substitute this into the earlier expression for P of A equals to summation n equals to 1 to n P of A by Bn into P of Bn. Let us consider an example for our better understanding. Let me explain you an example. Here the example is two balls are selected randomly. Here we are considering two balls. They are selected randomly. The first box contains two white balls and three black balls. In the two here we are considering two boxes. In the first box there are two white balls and three black balls. In the second box contains three white balls and four black balls. In second box there are three white balls and four black balls. What is the probability of drawing a white ball? Here they told here the question is, let us two balls are selected randomly. The first box contains two white balls and three black balls, and the second box contains three white balls and four black balls. So here they asked finally what is the probability of drawing a white ball among all the balls. Solution: assume that the two boxes have equal probability being selected. The probability of first box is equal to the probability of the second box. Here the probability of first box is equal to the probability of second box. Remember that the first box contains two white balls and three black balls, and the second box contains three white balls and four black balls. From that, therefore P of B1 equals to P of B2 equals to 1 by 2, that is 0.5. Before as per the before statement, the probability of box 1 is equal to the probability of box 2. From that, P of probability of B1 indicates box 1 and B2 is the box 2. P of B1 equals to P of B2, that is 1 by 2 equals to the probability is 0.5. Given they have asked us to find the what is the probability of selecting a white ball. For that, given the favorable event is selecting a white ball W. For that, P of W by Bn. B1 here, B1 is the box 1. First, we have to calculate what is the probability of drawing white ball in the box 1. So, for that, P of W is white, B1 is the box 1. That is, there are two balls in the box, two white balls in the box 1 and total 5 balls including red, black and white. That is so that's why we have written P of W by Bn equals to 2 by 5. When we calculate it, our final answer is 0.4 for P of B1 and P of W by B2. Now let us consider the white balls in the box 2. There are total balls are 7 balls. There are total 7 balls in the box 1 including black and white. In that there are 3 white balls. So the total probability is 3 by 7. That is 0.428. Here using the probability theorem, here we use by using the probability theorem, P of white ball equals to P of white ball in B1 into P of box 1 plus P of white ball in box 2 into probability of B2. That is P of white ball. Finally, P of white ball equals to, here the total the probability is 1 by 2. So we took 1 by 2 into 2 by 5. That is the probability of white ball in box 1 is 2 by 5 and the probability of white ball in box 2 is 3 by 7. Well, if we simplify that, we get the we get the answer as 29 by 70. If we still simplify that to 0.4143, because the probability always lies between 0 to 1. Thank you. Thank you for giving me this opportunity.